This is recording 2 for Project Echo. Hello again. My name is Rylan Mercer and I'm the owner of Mercer Mechanics here in Neo City 11. I've made progress on my entry for the main division of the original Mecha contest, or OMC. Competing against those massive corporations might seem daunting, but I'm confident that Echo, the Elite Covert Hybrid Operative, will stand out. With that said, I've planned an auxiliary jetpack, so let's dive into building a quick test bed for the electrical work. I forgot about this old set of electronic testing equipment I had from my days learning electrical engineering and some lab courses I participated in. I don't want anything fancy. I just want to expedite being able to test different thruster designs with the nuclear pack that will be part of the backpack. I was struggling to see how potential wiring would attach to the mech along with other parts I wanted, so I decided to hold off on the electronics for the time being. Maybe in the next recording. Instead, I decided to put in linear actuators and pistons. Similar to recording 1, I found it easiest to start at the bottom and work upwards. I mean, that's what I've been doing my whole life, so why change now? To start, I added armor with shock absorbers into the front of the feet in order to protect the wheels. The heel armor is similar in design but with vents. It needed to have space ground out to accommodate the rear wheel. I immediately got ahead of myself and started incorporating thrusters into the rollerblades. The inner child thrill of strapping rockets to my rollerblades was too irresistible to put off. Along with the rocket nozzle, I needed to add a starter system and air intake valves to make the engine functional. A microcontroller was added to help regulate the various components of the rollerblades. The controller was positioned away from the heated end of the feet, requiring conduits to ensure a protected connection. With the rollerblades mostly built, it is easier to determine where mechanical parts such as the pistons can be mounted. I've had success with magnetic joints in the past, so I defaulted to using them this time. They ended up being a great choice for roll motion control, but in general are no longer my default. I made a handful of different piston designs with various materials available, which were dependent on the use of the magnets. Clearance is mandatory between the pistons and the leg when roll and yaw motions are required. I was feeling good about the mobility of the side pistons, so I wanted to put an extra actuator into the calf to help with shock absorption. Here I used yet another piston material that I've had success with previously, but I added some simple features while it was in the lathe. Again, I had to add ferrous connectors to the end of the components because I opted for magnetic latches, which were definitely not ideal for the calf. This one right here. It works, but it is over-engineered for the lack of roll or yaw. At least with the pistons attached, I can determine where armor for sensitive components can be placed. I finally found a piston material that works, replacing the placeholder bolts I had been using for alignment. Continuing up the legs, the space underneath the thighs was very tight. The hips and knees are driven by 3-pole brushless motors, but due to the intended use of Echo, I wanted to install piston dampers in as many places as possible. While checking for clearance, I noticed a crack in the pelvis casing that had to be addressed. I suppose that's what I deserve for buying used car parts instead of building from scratch. Double micro dampers were attached to the thighs using more magnetic latches, and the input hydraulic fluid piping was connected with a swivel joint. Overall, I was a lot happier with this direction of design, and I'll definitely use more pinning and swivels on future piston connectors. Speaking of which, I immediately put the new process into use on the torso. It just made sense that the connection for the piston could also deliver the hydraulic pressure needed to make it function, rather than needing complicated parts with multiple degrees of freedom or separate hoses. Of course, I did use yet another material for the piston arm, and because it is ferrous, I ended up using magnetic latches on this tight joint. At the very least, I wanted to keep the arm and leg primary actuators similar to each other, so I reused the design there. With most of the functional mechanisms in place, I decided it was time to add some light armor for protection. I was struggling with joint armor ideas when, bingo! A side effect of these joint plates is interference that actually makes the leg pistons more compact. At this point, I wanted to make armor for the pistons based on some methods I've seen other creators use. Following someone else's blueprint felt off, like the design lost its edge. I had to trust my instincts and get back to doing things my way. So creativity can be tricky like that. Taking inspiration is easy, but it's just as easy to lose your way. Stepping back and recalling what made you successful is always a good idea. In my case, I found that simplifying the design helped. Stacking basic shapes always led me to a solid finish. Finally, I felt it was time to start on an exciting part I haven't built before. I have a lot of robotics knowledge and engineering know-how, so it was only a matter of time before I built some useful mech hands. I arbitrarily decided to use 4 fingers in the design, as it seemed like enough to interact with the environment. Want to take a guess how I made the wrist joint? I'm starting to think magnetic latches are a crutch in my design, but they work great here. I'll keep my mind open to other connectors, but it's hard to argue with results. A fellow engineer pointed out the lankiness of the design, and I realized the addition of the hand made the arm far longer than intended. No matter though, cutting and rewelding the forearm to be a more reasonable size is the least complicated thing I've done so far. Before continuing with more refinements, I finally made a parts tray, instead of using an old bucket. By trimming down the ankle joint, I was able to bring the pistons closer to the leg. I wasn't satisfied with how much the connection protruded from the sides. I milled out the piston rod to connect concentrically with the magnetic latch. A nylon lip helped to ensure no lateral slippage during use. In my opinion, the before and after of this change was well worth the effort. There is still space for rolling maneuvers without clashing. The initial layout from Part 1 has taken the design a long way, but it now needs improved aerodynamics. The hardened, brittle casing for the forward thrusters can be tricky to work with, but it's ideal for scribing. As the mech evolves, so does our community. At this time, a new infosphere analyst joined the cause. Thanks to Anjanya Singh for the support. Your encouragement keeps this project alive. Let's channel that energy into perfecting the forward thrusters. After cramming in spacers, the majority of the thruster engine block can be welded into the shoulder housing. A quick polish and a front intake grill makes for a more efficient shoulder design. There was a workshop incident where a tool got caught on one of the wall racks and pulled it off of the mounts. This isn't the first time, and this won't be the last time, so I decided to weld it in place. Always keep an eye out on how to improve. I felt particularly motivated, so I decided to create a full inventory of the sub-assemblies at this time. Excluding the incomplete jetpack and fasteners, we're already up to 52 components. Well, life comes at you fast sometimes. While it may not be the most fun activity to completely take apart a project, it's worth doing once in a while. Becoming familiar with every component and how they connect to each other can give some great insight into the design. For instance, the pelvis to torso connection is weak and will need to be addressed, even though I already added an additional magnetic latch. And since the ankles underwent heavy modifications, the ball socket joints have become looser than before. They might need reinforcement before adding more weight to the mech. But that's part of the journey, isn't it? The goal is progress, not perfection. Learning and improving with each step is what truly matters. I've built like 7 different piston assemblies and 4 different ones made it into the design. That's not ideal, but it's progress, and I'll do better next time. Every build is a lesson, and every mistake is a step closer to mastering your craft. So get out there, experiment, and keep pushing your limits. That's all from me, Rye at Most Mechanics. Take care. Oh, and thank you again to everyone who has been supporting my company. I appreciate it. End recording 2.